Okay, we're going to end our discussion of T-beams by doing one example where the compression zone goes down into the web. Um, as I said earlier, in most cases, the compression zone is going to stay within the flange, but this example goes into the web. And a dead giveaway that this is going to happen is that there is like a lot of steel. Okay, so if you look at this, 12 and a half square inches, that's a lot of steel. And really small ears, what I'm calling the ears of the TB. Okay, see how that's not very much wider than the width of the beam. Okay, so just what 30 inches on top, 14 on the bottom. The difference is 60. So only 8 inches extra on the sides. And so what's going to happen is because the steel is so high, T will be large. You'll need a lot of area of concrete to make T equal to C. And since the flange is not very wide, the neutral axis will go down into the web. And so if you see a beam that looks like this, like what you see here, it's kind of rigged to have the neutral axis go into the web. Okay, and okay, so what we're gonna do is solve this problem. And instead of breaking it, so earlier I talked about breaking a T section into two rectangles like this. Instead, what we're gonna do, we're gonna break it into three rectangles like this. But we're going to call this rectangle 1, and we're going to just combine these two into the second rectangle. They're equal, so that's going to be a2 over 2, a2 over 2. So we still have two rectangles, but the second rectangle is just split into two. This is handy because a1 is just our regular rectangle b times a. This will become apparent as we go through this. Okay. So you hope that the compression zone is in the flange. So you do T equals C. So here's T, and again, because that area of steel is so big, you'll have a large tensile force. And then because this is so small, when you solve for A, you get 8.16 greater than 7, which is into the web. And so even with this problem rigged, with such a high area of steel and a very low BF, we barely get the neutral axis deeper than the web, so deeper than the flange, so into the web. Okay, so we do have to assume that, I mean, we cannot assume that the compression zone is completely in the flange. It's not. And so you're going to break it into these two rectangles, as I said earlier. Rectangle 1, which is this rectangle here. Okay, it's nice because it has an area of B, which is 14. The width of that inside rectangle is 14 times A. And the width, the area of the two ears, remember I said is 8 inches on both sides. So it's 16 inches wide and it's 7 inches tall. So 16 times 7, or 112 inches squared. So the total area of the concrete in compression is 14A plus 112. 112, let me fix that, inches squared. Okay, so let's continue. So we're just going to do T equals C, solve for A. That's Fy. There's the very large area of steel. 0.85, that's F prime C. And again, that's the area of that T shape. We solve for A. Excuse me. A is 9.48, greater than the 7 inches. So yes, indeed, it is into the web. Okay, and then solve for C's and Z's. So let me cut and paste this picture and so you can, it'll be easier to see. So let me, um, let's see, I'll copy that and paste it down here. Oh, I guess that didn't work. So what we're gonna do, I'll just redraw it. So C1 was this rectangle, was 14 inches. This A was 9.48. And C2 was the two 8-inch by 7-inch rectangles. Okay, so in that area was 112. And so here we go, 0.85 F prime C. This area is 14 by 9.48. This area is 112. And so you get that. Okay, and the distance to the this rectangle, so it goes like this. Here's the steel. That's 9.48. So the distance to the middle of that was D minus 9.48 over 2. Okay, so that comes out that. And the distance from the steel to that, that's D minus half of this height, which was 7. So D minus 3.5 inches. That's this. And you do C times Z for the regular rectangle and the 2 ears, and you get 1655 kip feet. And so finally, MN is 1665 kip feet right there. I just repeated that line. Okay, and that's how you do a T-beam when the compression zone goes into the web.